Now, under hardness of water, we've treated temporarily hard water. And I said we have different methods of removing temporarily water. That is water that contains calcium hydrogen triisocarbonate 4 and magnesium hydrogen triisocarbonate 4. Number one, by boiling. It will break down the calcium hydrogen triisocarbonate 4 to give you calcium carbonate, which is a whitish substance and is not soluble. So when you boil, they add the soluble substance, which is calcium hydrogen triisocarbonate, becomes insoluble by forming calcium triisocarbonate 4, CaCO3. From CaHCO3, it forms CaCO3, which we filtered out. And we also use slaked lime, that's calcium hydroxide. When this is added to calcium hydrogen triisocarbonate 4 in water, it will precipitate out CaCO3, that's calcium triisocarbonate 4, which is also filtered out. Another method is using washing soda, that's sodium triisocarbonate 4. This also precipitates out the calcium and or magnesium ions, depending on what we use, by bringing them out as magnesium carbonate or calcium carbonate. Both are not soluble in water. And then we have sodium hydrogen triisocarbonate also formed as well. And the last method there for temporarily hardness of water is distillation. Now here, under permanent hardness of water, we also have the first method for removing or precipitating out calcium sulfate. We want to remove calcium sulfate, magnesium sulfate, any of these, calcium chloride or magnesium chloride. So any method I'm using here can be used for any of these compounds. When these compounds are in water, they are soluble. When they are in water, the water becomes permanently hard, and so it cannot be removed by boiling. And when you add soap to such water, you see the formation of scum, a whitish substance, and the water tends to be stubborn, except when you use liquid soap or powdered soap, which are all detergents. But when you use bar soap, definitely it will form a whitish substance because of the solubility of this compound. So we are looking for a way of adding chemicals to remove them out as insoluble substance. They are soluble in water, you can't see them. But when you add chemicals to them, they precipitate them out in form of calcium triisocarbonate 4, that's CaCO3. So the first method here is the use of washing soda. That's Na2CO3 plus calcium sulfate, for instance. Now when you add this together, there will be an exchange of radical, and then you have CaCO3 being formed and Na2, S of that sodium triisocarbonate, sodium tetrasulfate 6, which is soluble, and this is insoluble, and so it is filtered out. This is harmless when it is in water. Another method, you can use this for calcium chloride too. When you add this to washing soda, you still get calcium triisocarbonate 4 and sodium chloride. This is soluble and harmless. Why is like a salt? Why this is insoluble whitish substance. Now the second method we can use is sodium hydroxide. That's caustic soda. The first for temporarily we use slaked lime. This is caustic soda. And when we use this with any of the ions contain any of the compounds forming hardness of water, what we end up getting is an hydroxide. This is soluble in water. This is insoluble and is responsible for permanent hardness. So we want to remove this calcium ion in form of hydroxide. Calcium hydroxide is not soluble. Sodium sulfate is soluble. So the ions responsible for hardness is removed in form of calcium hydroxide. The same thing occurs when you use magnesium sulfate. Then the third method, the same also occurs when you use calcium chloride or magnesium chloride with sodium hydroxide. You will end up getting sodium chloride and calcium hydroxide. The calcium hydroxide is removed because it is not soluble, a whitish substance. We can also use washing soda. Just like I said, we use this method to also remove temporarily hard water. Let's assume we have calcium sulfate. I don't know why I like using this method. Or better still, let me use calcium chloride. Calcium chloride. Now, this will precipitate out the calcium in form of triisocarbonate, and then salt will be formed. Now, we also have distillation method. When you hits the water and then it reaches its boiling point, passes through the Liebig condenser. It will condense in form of pure water, leaving the ions behind. That's simple distillation. And then the last method is the use of permutate method, which is ion exchange resin. Ion exchange resin contains sodium aluminate, and so it's like a sodium aluminate triazosilicate form, and the surface is usually coated with sodium ions. Now, let's assume this is sodium, which is also known as sodium zeolite. Don't forget, sodium is soluble in water. When you add it to calcium chloride, for instance, which is responsible for permanent hardness of water, there will be an exchange of radicals. So you have calcium zeolite, which is removed, and then you have sodium chloride form. This is soluble in water. Now you want to recover your resin back, just pour salt, which is sodium chloride, back. You will get your, remove this. So when you add sodium chloride back, you will end up getting your sodium zeolite. Recover it back, and then calcium chloride is removed in form of a waste. So these are the 4 methods for removing hardness of water. And this hardness of water is the reason why deltas are formed and the riverbank where river water and sea water meet. River water does not contain ions, but it contains mud. Sea water contains salts, sodium ion, sodium chloride, sodium iodide, potassium iodide, all those ions, potassium, sodium, magnesium ions present in the seawater. When they flow over river water at the point where they meet, the ions will precipitate out or remove the clay and make the clay, the clay which are already soluble in the river water, will solidify out. It's just like adding alum to water. The dirt will coagulate and form clogs of particles that you can't even see before. You will start seeing them solidifying and settling down. So the ions in the seawater will remove the clay and make them to be hard, forming deltas at the base of the water. So this ends our classes. Watch out for the next video, which is on solubility. And before we treat solubility, we are treating types of solution. You need to know the principles behind solutions before we can move to solubility. Thanks.